Good morning, everyone. Mic is working well, I guess. Thanks for coming to today's session. And as you can see in the screen, we titled this panel as AI and Energy Shift, Opportunities in the U.S. Nuclear Market. My name is Chun Pae. I'm a partner at a law firm of Mayer Brown LLP based in New York office. And I'm very honored to moderate this panel with our great panelists today. We will be discussing very timely and important discussions today. So the intersection of energy transition and the AI revolutions. So first theme is talking about the two powerful transformations. So first is relating to the energy transition, which started about a decade ago and still continues as countries are trying to fight against climate change. The energy transition itself has raised a lot of interesting questions and provoked, ideas and stuff. Now we're facing another important transformation, the rise of AI. And AI needs data centers, and data centers needs energy. As you can see, it is a very energy-intensive industry, and data centers are on 24 hours. They never sleep, and it consumes a lot of energy. And in order to address both transformations at the same time, we need energy that is reliable and carbon-free. This is where nuclear energy comes into play. The United States is now working to extend the life of existing nuclear fleets, as well as supporting the development of new reactors, including conventional nuclear power plants, as well as new technology like SMRs, to meet the AI-driven energy needs. But this challenge cannot be solved by one country alone. So partnerships with countries like Korea becomes essential. To scale the development and share the risk and develop the supply chains and also train the next generation of nuclear workforce. All of them are very important, and South Korea has the right expertise and experience. This session is about exploring how we can collaborate in a concrete and actionable way. So I'm honored today to present the panel, joined by three global leaders across the nuclear ecosystem that covers utility, finance, and technology. They will bring rich and real-world experience to our conversation. So let me briefly introduce the panel today. On my left, Robert Dinaite, Vice President of Nuclear Engineering at Public Service Enterprise Group, Pseg. Pseg owns 5 nuclear power plants in the United States and operates 3 of them. He'll share how utilities are preparing for rising demand and navigating policy and infrastructure challenges. On his right, I guess, Bridget Posh, partner at ApolloglobalManagement. As many of you know, Apollo is a global financial powerhouse and investor, and she'll offer insights into what makes nuclear attractive and also challenging. And also, right next to Bridget, In-Sik Park, Executive Vice President of the Overseas Business at KHNP. KHNP is a global leader in nuclear technology, and he will bring deep expertise on project development, international partnership, and Korea's expanding role in the global nuclear market. So without further ado, let's just dive right in. So the first theme that we're going to discuss is to give a snapshot of the current landscape about the U.S. energy. So maybe I'll turn these questions to Robert first. Can you set the stage for us? For example, how do you see the U.S. power market evolving amid rising demand, and what's the biggest challenges, and how U.S. utility and power companies would adapt?
Yeah, thanks, June. First of all, just thank you for having me on the panel today to be able to discuss such an important issue with my distinguished panelists. I reflect on the presentation that we just heard during the kickoff and the title that's behind us on a great transition. To me, when I read those words and think about AI and data centers, I see a great disruptor. The forecast in the domestic United States energy market is expected to rise by 40% over the next 10 years. And the demand outpaced the supply in the next 3 years by 2028. The easy solution to something like that is simply just build new generation. But when we take a look at the US markets, for the last 20 years, they've been stable. Energy increases due to technology and electric vehicle use have been offset by energy efficiency. And the market structure that we have in place worked during that period of time. The markets are split into two different markets: a regulated market that primarily operates in the southern and western regions of our country. And in a regulated market, when you find yourself in need of a project like that, you can apply to your regulator to be able to get approval for a new generation. That new generation is then passed on to the customers through a rate base. And with that rate base, risks associated with that project is shared with the customers. Any delays or cost overruns then, of course, are passed on to the customers, and the customers at some point will challenge the regulated utilities to ensure that they finish on time. In a deregulated market, a market in the Northeast where our company operates, it's different. We bid our power into the market over a 3-year period, a 3-year horizon, and a build is going to take 5 to 10 years. So the market risk associated with understanding what the prices are going to be on the back end of that build is adding the risk associated with new generation. And that risk is borne specifically by the utility. If we take a look at the biggest risks associated with that, there's a couple. One is the financial markets associated with the $15 billion to $20 billion projects simply do not exist. They're being created pretty much as we're speaking today. In addition to back-end risks, the risks associated with what happens if there's a project overrun, what happens if the costs associated with the build is exceeded or the schedule is missed, adds a huge amount of uncertainty to that build. There's two other very important ones. If you take a look at the Vogtle units, the last 2 units to be built domestically, the cost overruns associated with those were really for a couple of reasons: supply chain, and having a robust supply chain, as well as labor and labor shortages. All of these risks are going to be the risks that have to be overcome. And the only way that we can do that is through partnerships. Partnerships between the utilities, the investors, the OEMs or the builders of the nuclear reactors, as well as the constructors. And then lastly, it's going to be who is going to purchase that power? Who is going to supply a power purchase agreement on the back end to be able to get some certainty associated with our builds? So that's the PPAs that we call them, the hyperscalers, or local or perhaps federal governments.
That's great. So maybe let's just step back and ask you another follow-up questions. What do you think is the role of the current nuclear fleets in the United States versus the interplay between new technologies like SMRs or other energy sources in the regional energy mix?
Yeah, thanks, June. If I think about nuclear power and climate change, nuclear power has to be part of an all-of-above solution for climate change. You can't simply go with renewables without having baseload energy. So because of that, when we reflect on our nuclear fleet, the most important thing for us right now is safe and reliable operations of our existing nuclear fleet. The nuclear energy market is coupled, and what I mean by that is if we have an event, if we have an issue anywhere in our industry, including the world, the public support for nuclear power could diminish. So the first priority for us is safe and reliable operation of our nuclear fleet. Now, with that being said, we're taking a look at our current fleet to say, what, from an additionality standpoint, do we need to do to be able to get the most out of our current units. We propped up a $1 billion project associated with power uprates to get additional generation out of the 3 units that we currently operate. We're also taking a look at license renewal and license extension. All of our nuclear plants were originally licensed for a 40-year operation. We've done license renewal to take those to 60 years. And right now our Salem units, we're looking to do a subsequent license renewal to extend those out to 80 years and potentially beyond. So maximize the value of our current assets. And we can do that faster than a new build. So that's the first thing for us. The second piece is we wanted to be ready in the market if new construction came about domestically. So we have something called an early site permit. An early site permit is the first step in our licensing process to be able to license and build a new reactor on our site. We saw our site as having potential value because we already had commodities and resources on our site to leverage for a new build. Things like security, supply chain, warehousing, a fire department, common maintenance organization, all exist on our site, and we could share those resources to any potential new build that we have. So we wanted to set ourselves up. The however is we're not a nuclear developer, and we need the support of partners to be able to do such a large-scale build within our site. Now, if I think about what technology would we select, and June mentioned SMRs, or small modular reactors. What technology is going to be beneficial moving forward? The biggest challenge that we see right now is for a small modular reactor. They're 300 megawatts typically. There's one approved design domestically, and that's through NuScale. That's a 77 megawatt unit. When we take a look at a first-of-the-kind build for something like an SMR, we have to ask ourselves, what is the likelihood that that build is going to be on budget, can be built at a lower cost, and at a reduced schedule in comparison to a large light water reactor? The small modular reactors carry additional risk, but a lower capital investment. So that's what's making them attractive to some of the hyperscalers. However, on the backside of that, you would rather have a large unit to minimize the number of personnel that you have to run those units. So right now, technically, we say we're agnostic associated with a small modular reactor or a large light water reactor. But the first thing we need is partners, and partners to be able to facilitate a bill on our units.
So speaking about partners, I'll turn these questions to Mr. Park, Pseg. So I understand KHNP in the past delivered numerous nuclear projects worldwide. So in light of the recent executive orders relating to nuclear industry, what changes do you foresee in the US and whether that would present any business opportunities for Korean companies?
Thank you. I'm Pseg Park from KHNP. I'm very honored to give a speech to the distinguished guests. As you know, President Trump recently announced 4 executive orders on nuclear energy. This shows that U.S. energy policy is moving strongly toward nuclear power. The first important point is the policy direction. Nuclear power is no longer seen only as green energy. It is now placed as a key pillar for U.S. energy security and economic competitiveness. For this reason, new build, long-term operation of existing fleets, and advanced reactor deployment are now national priorities. This gives investors and utilities a clear base for long-term planning. The second point is regulatory change. The orders call for faster licensing of advanced reactors, simpler permits for new infrastructure, stronger cooperation among federal agencies. The U.S. system is generally transparent about the regulation and risks. That is a strong point, but it is often slow and complex to manage those risks. Finally, there will be more room for international cooperation. The others highlight strong supply chains, workforce training, and technology leadership. The U.S. brings global innovation and a large market. Korea has constructed and operated nuclear power plants for more than 50 years without single interruption. Korea brings proven success in building and operating nuclear reactors on time, within budget, with a robust supply chain. In conclusion, these executive orders are not just about creating new chances. They signal the U.S.-Korea nuclear cooperation can meet America's growing energy demand and climate change together. As for our cooperation, I wanted to chorus Korea, United States, as in chorus like a singing choir. Thank you.
Thank you, Inshik. I guess the on time and within budget is a key strength for Korean companies. And in order to make the synergy, there's another important component, financing. We need money to build a new nuclear power plant. So this question is to Bridget Yu. So what kind of nuclear investments are viable today? And from your perspective, what makes nuclear investments attractive or challenging?
Thank you, and it's a pleasure being here. I'm going to use a few things that Robert mentioned earlier. It's nuclear is capital intensive. It takes several years to put together. It is costly. You have jurisdictions that are regulated, not regulated. Each of them have their challenges when you're putting financing together. I think what's important, first of all, is understanding the project, understanding the cost of putting together, the flexibility that's needed, again, which jurisdiction you are in, how predictable that cash flow is. As Robert mentioned, in some jurisdictions, if it's a regulated asset, if you have you can pass a minimum price into it, so you can create some predictability. All those points are very important to understand how to finance those projects, which are very long in nature. So the key is having the right capital to finance that. So that goes a little bit to what I do, into what Apollo does. So Apollo today is roughly north of $800 billion of assets under management, of which I assume roughly 2/3 is coming from pretty much from our insurance balance sheet. And that's very important. Why? Because the insurance balance sheet, the one that we have, we consider it as a patient capital, permanent capital. Why is that important? That's important because it allows us to finance projects like what Robert mentioned. Having a permanent capital, having a capital that does not need to be recycled in 5 years, having a capital that does not need the liquidity will allow us to tailor capital solutions to companies that are putting those projects together. So I think that's very, very important when we think about financing this type of opportunities. It could be nuclear, it could be data centers, it could be basically more bespoke, more complex type of transactions. Again, having the right capital. Now, the other point to mention is, Robert, feel free to jump in here, is also making sure that we are using the cheapest possible capital to finance those projects, right? So we can make them viable and ultimately be able to finish on time at a cost that makes sense, not only for the company, but for the users of that product. And again, for that, if we think about our insurance capital, that allows us to provide the cheapest cost of funding for those entities. Now, the other important part of thinking about financing is what is basically, are we financing the asset? Are we financing that project? Are we financing the company? Is which type of solution, which type of capital solution are we providing to this company? So that partnership that, Robert, you mentioned is very important. It's not only about one deal or one opportunity. It's making sure that we create a partnership and we are able to provide a capital solution to the company. Sometimes it might need to be a structural equity. Sometimes might be a purely senior unsecured type of transaction that is debt with some tweaks that allows that financing to mirror as much as possible. So for instance, we recently have done a transaction with EDF. We financed roughly equivalent in dollars, $6 billion of the Hinkley Point C in Britain, which I think it's probably, and Robert correct me, probably over the last 2 decades, probably one of the first nuclear facilities to be focused on. That is a project that has already been in place. It still has some construction. So from a complexity perspective, at least from the Apollo side, I would say probably one of not as complex as transactions as we have done with Intel, also not too long ago. But the way we financed EDF, first providing the certainty of the $6 billion in sterling, which is one of the largest private transactions in sterling that has ever been done. Probably 7 times larger than any of their EDF's public bonds that they have done. But 2, we were able to provide tailored solution on that senior unsecured bond that the capital markets probably would not be able to do, or not at a cost that would be interesting for EDF. What were those, call it those solutions or those tweaks? One, there was still a construction stage. So allowing to provide a delayed draw in a senior unsecured bond was important for them. 2, they had a view on interest rates over the next several years and the certainty of financing $6 billion that make this transaction very important for EDF. So with that, let me pass it back to you.
Yeah, thank you. So to summarize, I guess what you're saying is the duration of the investment create a risk, and the size of investment can be an issue, and therefore you need some sort of a combination of capital, both from public and private, and even from the private, like different levels of capital stacks. That might be the solution to get there or scale up. So maybe we can switch to the next topic that talks about challenges and risk mitigations. So this question is to you, Inshik. What do you think, based on your experience, are the main barriers of expanding nuclear power in the United States? And any sort of a suggestion how we can overcome those barriers?
Yeah, thank you. In my view, there are 3 main barriers to expanding nuclear power in the U.S. First, as you already told, she already told about the risk of financial risk. Nuclear plants need, as you know, huge upfront investment, and the payback takes decades. Some reactor projects in the U.S. face both cost and schedule blunt. This has made investors cautious, and still financial risks remain a challenge. Second, complex regulation. As you know, the U.S. safety regulation system is transparent and strict. But the full process from planning to licensing to commercial operation can take more than 10 years. So close coordination among federal government and state government and the local stakeholders is very essential. If the process takes too long, the start of a new project is delayed. Third, supply chain weakness. Because the U.S. stopped building new nuclear power plants for many years, the number of suppliers has dropped sharply. For long lead and complex components, their capacity is especially limited. To solve these problems, we need a new financial model, faster regulatory process, and strong partners. Government guarantee public-private partnerships and the long-term power purchase agreement, PPA. These tools can provide a stable financial foundation. At the same time, we need a standardized licensing based on advanced reactor features. We also need clear approval timelines. And we need global partners who can jointly procure key components and share inventories. These steps will help reduce risks. Thank you.
So it sounds like both regulatory roadmap and a partnership between the U.S. Korea is the key to overcome those barriers.
Yeah.
So maybe can we hear that same story from the U.S. perspective? How do you think the U.S. utilities and policymakers should cooperate with counterparts in Korean company, and what would a strong U.S.-Korea nuclear alliance would look like?
Yeah, thanks, June. Let's talk about policymakers for a second. You know, things are changing rapidly. Every day I read about a new partnership or a new agreement between a hyperscaler, a utility, and you know, perhaps one of the larger OEMs or reactor builders. But if I take a look around our landscape domestically, not many people are moving dirt. So announcements are cheap. PowerPoint reactors are not something that can be built. And the best way our policymakers can support us is something that we've seen here recently. We saw the South Korean government pledge $150 billion to the American infrastructure. And then our current administration signed an executive order to build 10 light water reactors, or at least initiate the builds here by 2030. So our policymakers are setting the stage for us. But here's the challenge, and I promised myself I wouldn't joke around today. I like to tell jokes. But I will mention one thing, and it was a great line that I heard during a presentation. Domestically, there's a race for bronze. No one wants to be the first one to be building one of the new reactors. Everyone wants to be the fast follower, but nobody wants to be first right now. So our policymakers eliminating those barriers or setting up some risk sharing or cost sharing with the fast followers so someone will take the lead. You know, I mentioned our site having an early site permit. We also have a large industrial port on site where we can take large pieces from anywhere in the world that can get barged and shipped in. So if I shift over to a transition to what does a U.S.-Korean partnership look like, I think our policymakers have set the stage. I think our race to bronze is underway. I think we're waiting for the one utility that's going to be the first to really announce that they're going to build either an APR 1400 or an AP 1000. And the next step for us is going to be, what do those partnerships look like? Is it going to be a traditional owner-operator? Will it be a partnership where somebody's going to be supporting the build and someone else buying the power on the back end? But this much I can say with certainty. If I take a look, the biggest challenges that we had domestically with the Vogtle units were who we picked as the constructor. There are many challenges. If you take a look at those builds, approximately $6,000 per kilowatt was attributed based on an MIT study, so we can at least say that's going to be accurate. That was based on who was selected for those builds. There was also a bankruptcy involved, a pandemic throughout that. So we believe that there's going to be cost savings. The benefits that we can have is for Korea and South Korean companies, they've been building reactors over the last 30 years continuously, on time, on budget. Domestically, over the last 20 years, we brought 3 new reactors online. We can leverage that proficiency and experience from the Korean engineering, procurement, and construction companies domestically to be able to facilitate our builds and start eliminating the risks. That's going to be the partnership that we're looking to establish between the US as well as Korea.
So matchmaking is very important, and you have to find the right partners to make that happen.
That's what my mother told me, yeah.
So since we discussed snapshot of where we are, and then the challenges we have and how to mitigate the risk, now the next theme is to discuss what we think will be the most ideal US-Korea nuclear alliance would look like. So let me start this question to In-sik. So you have experience dealing with global projects like in UAE and Czech, and I guess that'll offer great insights. So what lessons do you think are most relevant to the United States?
The UAE Baraka project now in the last final stage. Korea delivered 4 large reactors within 10 years after signing the contract. During that time, we completed construction, commissioning, and commercial operation. We met the schedule, quality, and safety goals. Even in the difficult environment of the UAE, this showed the nuclear project need more than technology. They also require strong management, risk response, and communication skills. In the Czech Republic, we recently signed a contract, and the success came from building trust. We stayed engaged with the government, regulators, local communities, and suppliers. This strong relationship gave us a good result. As I mentioned earlier, the US market is transparent in regulation and the project structure. So I think unexpected risks are fewer, but there are built-in risks such as the supply chain, regulation, public acceptance, and the labor conditions. These are very hard to solve. For effective project delivery, we need a specialized local developer that enables a smooth, large-scale project. Nuclear construction takes place for a long time, and so it carries various risks. It is essential that we have a developer who can widely coordinate and address a variety of issues that may arise during construction in the US. Also, risk sharing is the key. By sharing risks, we can reduce the burden, speed up decisions, and move project forward. KHMP is not just a supplier. We want to be a partner who shares the responsibility and solve the problems together. Thank you.
Thank you. So I think we're kind of coming back to the same thing of doing right matchmaking, find the right partners to navigate through the local regulatory issues and workforce issues and whatnot. So for example, Pseg is very well versed in that area. So what do you think an effective US-Korea nuclear partnership model will look like, and how both parties can share opportunities and risk?
Yeah, sure. I touched on a few of these, but I want to go back and highlight a couple more. One is as a constructor, project manager of a site. You know, we heard on schedule, on time, and on budget. That's going to be the most important to minimize the risk associated with the investments. The second piece, and this is probably the one that, you know, my trip to Korea I'm going to be walking away with, is we met with one of the large suppliers of transformers. They're taking orders right now for 2030 and beyond. 5 years out, any builds that we have, we're going to need transformers. I'm not worried about the small modular reactor pieces and parts. We'll figure that out. We'll get the right vendor. We'll get the right infrastructure built in. But turbines, transformers, breakers, and that robust supply chain and the partnering and carrying the risk associated with the large components, that partnership is going to have to be established. And a shared risk associated with building the infrastructure and building those parts to be able to be delivered on time, to be able to support any, whether it's a small modular reactor or a large light water reactor, all of those are going to need something similar like transformers.
Thank you. Now we only have 1 minute. I'll ask Bob. So in one sentence, what is the most urgent and promising opportunities in US-Korea collaboration, you think?
Yeah, I think, just not to repeat myself, if we go back to what success would look like, safe and reliable operation of our existing nuclear fleets, sustaining, I'll say, or at least changing our theme from the great, what I'm calling disruption, to a great transition, to then be able to translate that into safe, affordable power for our customers, and doing that through new generation and with a partnership with new supply chains with a Korean-US relationship.
Thank you. Thank you for your insights and helpful discussion. And we can wrap this program by a big round of applause to the panel. Thank you.